Hey, welcome. Today we are pulling back the curtain on something you probably do every day, streaming a show. We're going to go on the invisible, high-speed journey your favorite series takes to get from a studio server all the way to your screen. Let's get into it. I mean, it feels so simple, right? You click a button, the movie starts. But behind that one little click, there's this absolutely mind-bogglingly complex relay race happening across the entire globe, all in a matter of milliseconds. It's kind of wild when you stop and think about it. And just to give you a sense of the scale we're talking about, look at this number. At peak times, just one company, Netflix, accounts for about 15% of all the downstream internet traffic on the planet, the entire planet. So managing that absolute fire hose of data is, without a doubt, one of the biggest engineering challenges of our time. So, how on earth do they pull it off? Well, the whole journey actually starts way before you even think about what to watch. The first step is all about preparing the binge, and that means figuring out how to shrink a gigantic movie file so it can actually survive the trip across the internet. And the key to that is something called video compression. Honestly, the best way to think of it is like a super sophisticated form of digital origami. Engineers use these incredibly complex algorithms to, fold and tuck away all the redundant information in a video, making the file size way, way smaller, all while trying their best not to mess up the quality. Now, here's where it gets really interesting, because this process has evolved so much. It's not just about one big compressed file anymore. Netflix actually pioneered this method called per-title encoding. What that means is for a single episode of your favorite show, they create hundreds of different versions. All of them are optimized for different devices, different internet speeds, you name it. And they do it using these super efficient new rule books, or codecs, that can cut the data needed by up to 40%. Okay, so once all those files are shrunk down and ready to go, the next massive challenge is distribution. I mean, how do you get those files physically close to over 300 million subscribers in 190 different countries so they're ready to stream at a moment's notice? The answer is something called a content delivery network, or CDN. And my favorite analogy for this is a pizza chain. Instead of having one giant kitchen in, say, California trying to deliver pizza to the whole world, which would be a disaster, they build smaller kitchens in every single neighborhood. A CDN does the exact same thing, just with computer servers full of video files. And this is where Netflix got really, really smart. They didn't just rent space on a normal CDN. They built their own from the ground up. It's called Open Connect. And they actually partner with your internet service provider to put their own little server boxes preloaded with the most popular shows in your area directly inside that ISP's building. This means the movie you want to watch might literally be stored just a few miles from your house. And that is the secret to cutting down lag. All right, so we've shrunk the file and we've shipped it all over the world. Now we get to the moment of truth. You press play. And this is where the real magic kicks in. The stream starts adapting, in real time, to whatever your Wi-Fi is doing at that exact second. But before we get into how it adapts, you gotta understand this crucial handoff that happens. Everything you do before you press play, browsing the catalog, getting recommendations, that all happens on Amazon's massive cloud servers. Netflix calls this the control plane. But the very second you hit play, you are seamlessly passed over to Netflix's own custom-built network, Open Connect, the data plane. It's this entire global system built for just one thing: blasting video to you as fast and efficiently as possible. The tech that makes this all possible is called adaptive bitrate streaming, or ABR. The bitrate is just how much data you're using for each second of video. So instead of trying to download one giant movie file, your show is chopped up into these little bite-sized chunks. Your device downloads them one by one, and here's the clever part, it can instantly decide to grab the next chunk in a different quality based on what your internet is doing right now. So what's really happening is this constant, silent conversation in the background. Your video player is acting like a little scout, constantly checking the road ahead, your internet speed, your connection stability, before it ever asks for the next piece of the movie. It's always asking a really simple question. Is the Wi-Fi good? Is the network totally clear? And if the answer is yes, it confidently says, okay, send me the next chunk in beautiful, crystal clear high definition. It knows the road is wide open, and it can download that piece with plenty of time to spare. But what happens if things change, right? Maybe someone else in your house starts a massive download, or you just walk into a room with a spotty Wi-Fi signal. Well, the player detects that drop in speed instantly. And before you can even notice a problem, it preemptively asks for the very next chunk in a slightly lower quality, smaller version. Yeah, the picture might get a little less sharp for a second or two, but it's a tiny price to pay to avoid the single most hated thing in all of streaming, that dreaded buffering wheel. And this isn't some secret Netflix magic trick. The rulebook for how all this adaptive streaming works is actually an open international standard called MPG-. Companies like Google, Microsoft, and Netflix, they all work together on these guidelines to make sure streaming just works for everyone. Okay, but as we've seen, a good stream is about way more than just dodging that buffering wheel. There's a whole field of science dedicated to figuring out what actually makes a video feel high quality to a human being. It's called quality of experience, or QoE. And it's this really holistic idea. It gets that your satisfaction is a mix of technical stuff, like the number of pixels, but also human stuff, your expectations, and even the context. I mean, are you watching on a tiny phone screen or a giant 4K TV? It all matters. So how do you even measure something that's so subjective? Well, there are basically two ways. You can do subjective tests, where you get real people in a lab to literally sit and rate videos. Or you can do objective tests, where you use mathematical models to try and predict what those human scores would be. And this is where things get a little bit futuristic. Netflix developed this really advanced metric called VMath. And it's not just counting pixels. It actually uses machine learning that's been trained on how humans see things to predict how good a video will actually look to a person. And this is a total game changer, because it lets them shrink a file down to the absolute smallest size possible without you, the viewer, even noticing the quality dropped. It's all about better pictures using less data. So we have seen this incredible, complex journey from the studio all the way to your screen. But this technology, of course, is never standing still. And the next big wave of challenges is already coming. So let's just quickly recap the whole thing. We've got 5 key steps. First, preparation, where that video gets compressed into hundreds of versions. Second, distribution, where it gets sent all over the globe through a CDN. Third, the handoff, that moment you press play. Fourth, the constant real-time adaptation by your player. And finally, experience, using smart metrics to make sure it all looks great. And that really brings us to our final thought. The system we've just walked through is a modern marvel, for sure, but the demands on it are only going to get bigger. With 8K video, massive live sports events, and truly immersive virtual reality right around the corner, the real question is, how will this invisible, essential infrastructure keep evolving to deliver the future?